of California, San Diego, La Jolla, California, USA. 3 Department of Psychology and Program in Neuroscience and Cognitive Science, University of Maryland, College Park, Maryland. USA. 4 Center for Neuroscience Imaging Research, Institute for Basic Science, Suwon, South Korea. Correspondence, M. Justin Kim, Daeun Park. Received, October 9, 2024. Revised, April 3, 2025. Accepted, April 10, 2025. Funding, this research was supported by the National Research Foundation of Korea, NRF 2022 R1A2C10911871. Keywords, conscientiousness, grit, heart rate variability, self-control. Abstract. Grit is a personality trait, conceptualized as perseverance of effort and consistency of interests in long-term goals. Previous research has shown that grit is associated with various positive outcomes, including well-being. Despite extensive research on grit, most studies relied on self-reported measures rather than objective measures. To address this gap, our study investigated the relationship between grit and physiological responses, focusing on resting state heart rate variability, HRV, a physiological marker of well-being and adaptability. Additionally, we examined whether this relationship was unique to grit and not explained by other related psychological constructs, i.e., conscientiousness and self-control. A total of 206 healthy college students participated in this study. MAGE equals 21.03, SD equals 2.48, age range equals 18 to 33, 111 women. Results of hierarchical regression analyses showed that grit significantly predicted resting state HRV measures, i.e., RMSSD, SDNN, and HF, even after controlling for conscientiousness, self-control, age, gender, and respiration rate. These findings suggest that grit may play an important role in maintaining improved biological responses in daily life, beyond the effects of neighboring constructs. 1. Introduction. Grit is defined as a non-cognitive ability to persevere and maintain consistent passion for long-term goals even in frustrating situations, Duckworth et al., which is usefully described by its two subcomponents: perseverance of effort, PE, and consistency of interest, CI. Grit has been suggested to be associated with various positive outcomes, including academic achievement, Bowman et al., Duckworth et al., Zhang et al., career adaptability, Gregor et al., Lee et al., subjective well-being, Zhang et al., Jin and Kim, Zhang et al., and physical health, Knopf et al., Reed et al., Rhodes and Giovanetti. For example, college students with high levels of grit were less likely to change majors and demonstrated a greater grade point average, Bowman et al. They also showed greater career adaptability through
career exploration and decision self-efficacy, Lee et al. Furthermore, because gritty individuals tend to perceive frustrating situations as less stressful, Knopf et al. They experience less burnout and better subjective well-being, Dam et al. While prior studies have highlighted the positive consequences of grit, an ongoing debate concerns the incremental predictive validity of grit over conceptually related psychological constructs within its nomological network such as self-control and conscientiousness, Crete et al. Jaehoon Yu and Boyun Kim contributed equally to this article. This is an open access article under the terms of the Creative Commons Attribution Non-Commercial License, which permits use, distribution, and reproduction in any medium, provided the original work is properly cited and is not used for commercial purposes. Copyright 2025. The author, S. Psychophysiology, published by Wiley Periodicals LLC on behalf of Society for Psychophysiological Research. Psychophysiology, 2025. 62E70064 https://doi.org/10.1111/sci-p.70064 1 of 10. 146989886, 2025, 5. Downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for rules of use, OA articles are governed by the applicable Creative Commons license. Ponik et al. Schmidt et al. Vassigny et al. Although these traits are conceptually and empirically related, Duckworth et al. Duckworth and Gross, they are not identical. An increasing number of studies have shown that grit uniquely explains motivational, cognitive, and emotional outcomes above and beyond these neighboring constructs. Duckworth et al. S. Grace Winkler et al. Gorin et al. Zhang et al. Suzuki et al. For instance, grit predicted high school graduation. S. Grace Winkler et al. Grade point average, an academic goal motivation among college students. Duckworth et al. Werner et al. Even after controlling for conscientiousness. Similarly, grit had incremental utility when predicting individuals' mental and physical health outcomes. Ho et al. Quan. For example, one study showed that PE predicted subjective well-being beyond conscientiousness. Quan. Also, a recent meta-analysis showed that grit predicted subjective well-being above and beyond conscientiousness. Beta equals 0.38. Ho et al. Despite the evidence supporting the beneficial effects of grit, most previous research has relied on self-report rather than objective measures to examine its relationship with health outcomes. For example, in a study by Sharkey et al., individuals' healthcare management skills were measured using a self-report questionnaire, including items like, do you follow up on any referrals for tests or check UPS or labs? Accordingly, a recent review paper suggested that future research can also generate stronger evidence on the construct validity of grit through exploring how grit and its dimensions may relate to specific neurocognitive and physiological processes. Datu, p.11. Thus, incorporating a wider range of objective and physiological measures could offer better insight into the effect of grit over and above the related constructs. To address this, we tested whether grit was associated with physiological features beyond self-control or conscientiousness. Specifically, we focused on heart rate variability, HRV, given its utility as a physiological indicator of health outcomes. Heiss et al. Kemp and Quintana. HRV measures the difference between successive heartbeats on a millisecond scale, which is known to represent the status of the autonomic nervous system. Rajendra Acharya et al. According to the recently proposed neurovisceral integration across a continuum of time, NIACT, model, higher HRV is an indicator of healthy vagal function assisting in everyday psychological moments as well as the ability to adjust flexibly to changes in the environment. Higher HRV significantly contributes to better physical and mental health and decreased risks of mortality in the long run. Kemp et al. Supporting the NIACT model, empirical studies have shown that higher HRV is related to affective, cognitive, and psychological flexibility. Allen et al. Grahl and Reed, Howell and Hamilton, Keene et al. As well as better physical and mental health and healthy longevity. Kemp and Quintana, Zulfikar et al. Given that HRV is associated with the ability to adapt to unfamiliar situations, some researchers suggested that HRV might be related to an individual's personality characteristics. Geisler et al. Huang et al. Shepard et al. Sylvia et al. Specifically, high levels of cheerfulness and calmness help people engage in more emotional regulation, example refocusing, reappraisal, leading to higher HRV during rest. Geisler et al. Furthermore, another study showed that the big 5 dimensions of neuroticism and openness, as well as trait anxiety, were associated with lower HRV during a resting period. Shepard et al. Overall, these results demonstrated that the positive aspects of one's personality were associated with higher HRV indices, i.e., high levels of HRV, indicative of adaptive psychophysiological functioning. Although empirical work examining the relationship between grit and HRV has been scarce, there is one study investigating such relationships while actively engaging in a task, Sylvia et al. This study demonstrated that individuals with higher PE regulated their psychophysiological responses more flexibly, i.e., increased HRV, during tasks. Although this pioneering work provides valuable insights into the relationship between grit and HRV, it did not examine whether these effects remain significant when controlling for self-control and conscientiousness. Additionally, the study has a small sample size, n equals 36, limiting the generalizability of the findings. Moreover, changes in HRV during tasks may reflect temporary psychophysiological adaptations to environmental challenges, Kemp et al. In fact, HRV during tasks can be affected by the characteristics of the tasks, such as cognitive workload, Luke Casado et al. In contrast, resting state HRV may manifest an individual's trait like psychophysiological resources, Kemp et al. Thus, resting state HRV may be a promising psychophysiological feature in explaining personality traits, as it is more apt to discuss how individuals differ in their stable behavioral patterns that influence their responses to various life events, rather than just a single event, de Young, Nettle. Therefore, with over 200 participants, we aim to provide initial evidence. Initial evidence of how grit is related to resting state HRV, particularly in comparison to other relevant constructs, i.e., self-control and conscientiousness. We hypothesized that gritty individuals would show high levels of HRV in a resting state. Gritty individuals maintain a strong positive attitude and experience more happiness than others not only upon facing difficulties, Gregor et al., Lee et al., Toyama, but also in daily life, Zhang et al. Kahn and Kahn. Their tendency to see daily setbacks as temporary and opportunities to learn helps them perceive situations as less stressful than others, Estevez et al. Li, Yang et al. Furthermore, gritty individuals are less likely to show significant stress responses to the minor ups and downs of stressors. Indeed, gritty adolescents and adults had lower levels of perceived daily stress, Noft et al. Li. These characteristics can lay a foundation for grittier individuals to have better autonomic regulation and higher resting state HRV, reflecting their stable behavioral patterns and effective stress management. In this study, we collected resting state HRV data over a 10-min period and linked it with participants' self-reported grit using hierarchical linear regression analyses. To address the conceptual validity of grit, we included two covariates, i.e., self-control and conscientiousness, alongside grit when predicting HRV indices. We hypothesized that individuals with higher levels of grit would exhibit healthier vagal function, indicated by higher 2 of 10. Psychophysiology, 2025. 146989886, 2025, 5. Downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions, on Wiley Online Library for rules of use. OA articles are governed by the applicable Creative Commons license. Scores on HRV measures. Furthermore, we anticipated that grit would provide additional predictive utility for physiological measures beyond conscientiousness and self-control. 2 methods. 2.1 Participants. Our study was approved by the Institutional Review Board of the Authors University. Written informed consent was provided by all participants prior to the beginning of the experiment. We recruited 211 university students who were either enrolled in Introduction to Psychology courses, N equals 143, or received monetary compensation, N equals 68. All participants were Korean. Each participant received extra credits or 20,000 KRW, 15 USD, for participation. 3 participants who did not pass at least one out of the 2 attention check questions, example answer with strongly agree to this item, and 2 participants who were excluded during pre-processing due to low-quality electrocardiograms, ECG, data were omitted from further analyses. Therefore, our final sample included 206 participants, MAGE equals 21.03, SD equals 2.48, age range equals 18 to 33, 111 women. 2.2 Procedure. When signing up for the study and on the day before participation, participants were instructed not to smoke, eat, drink, or exercise within 1 to 2 age before the study session, in line with previous studies, Hallman et al., Jennings et al., Lee et al., Ottaviani et al., Wells et al. As these factors may impact HRV measures, Bowden et al., Romanois et al. Additionally, individuals taking any medication were not eligible to participate. Upon arriving at the laboratory, participants were given instructions about the procedure in a quiet room. Before starting the experiment, participants self-reported their intake of nicotine, food, and beverages within the past 1 to 2 age and indicated whether they were taking any medication. Participants who reported consuming nicotine, food, or beverages, or indicated that they were currently taking medication, were not allowed to take part in the study, N equals 1. Next, participants completed a series of questionnaires online, which took approximately 5 minutes in total. All questionnaires were translated and back-translated by corresponding authors, who are fluent in both Korean and English. After finishing the survey, the experimenter asked participants to attach 3 patches to their body, right clavicle, left iliac crest, and right ankle, to measure HRV. The ECG were recorded for 10 minutes. During the data recording, participants looked at the blank screen until the recordings were done. 2.3 Questionnaires. 2.3.1 Grit. Grit was measured using the 12-item grit scale, Duckworth et al., which was translated into Korean. Grit has 2 facets, CI, consistency of interest, P, perseverance of effort, and each facet was measured with 6 items on a 5-point Likert scale. 1 equals strongly disagree, 5 equals strongly agree. The average grit score was calculated by averaging the P, example I am a hard worker, and the reversed scored CI, example I have been obsessed with a certain idea or project for a short time but later lost interest. Therefore, higher scores indicate higher levels of grit. Internal consistency of the scale, indexed by Cronbach's alpha, was alpha equals 0.77, CI, alpha equals 0.73, P, alpha equals 0.77. 2.3.2 Self-control. We measured self-control using the 11-item Korean version of the Brief Self-Control Scale, BSCS, Hong et al. On a 5-point Likert scale, 1 equals strongly disagree, 5 equals strongly agree, which was originally developed by Tangni et al. BSCS measures 2 aspects of self-control, self-discipline, example I am good at resisting temptation and I have a hard time breaking bad habits, and concentration, example I am able to work effectively toward long-term goals and I am lazy. Negatively worded items were reverse-coded so that higher scores represent greater self-control. Internal consistency was Cronbach's alpha equals 0.80. 2.3.3 Conscientiousness. Conscientiousness was assessed using the translated 12-item conscientiousness subscale of the Big 5 Inventory 2, BFI2, Soto and John, which was administered on a 5-point Likert scale, 1 equals strongly disagree, 5 equals strongly agree. Conscientiousness consists of organization, example keep things neat and tidy and tends to be disorganized. Productiveness, example is efficient, gets things done and has difficulty getting started on tasks. And responsibility, example is dependable, steady, and sometimes behaves irresponsibly. Subcomponents. Negatively worded items were reverse-coded such that higher scores indicate greater conscientiousness. Internal consistency was Cronbach's alpha equals 0.85. 2.4 Heart rate variability assessment. To obtain HRV measures, we carefully followed standardized guidelines in psychophysiology, Quigley et al. And previous studies, Fanti et al., Lee et al., Watford et al. ECG was obtained using Biopac MP36, Biopac Incorporated, Santa Barbara, CA, at a 2000 Hz sampling frequency. https://www.biopac.com/wpcontT/uplo@s/ecgguide.pdf. We attached 3 electrodes to the participants for the configuration of a lead 2 ECG. The electrodes were placed as follows: a negative electrode below the right clavicle, a positive electrode above the left iliac crest, and a ground electrode on the right ankle. ECG data was pre-processed by the Cubios software v.4.1.0, Tarvainen et al., with a 1 Hz high-pass filter and moving average filtering. https://www.kubios.com/downloads/HRVSCIENTIFIC SERSGUIDE.pdf. Cubios automatically detected R waves by adapting a QRS detection algorithm that corrects inaccurate R peaks, including ectopic beats, Siliponen and Tarvainen, for its validity. Specifically, detected artifact beats are replaced by a 4 Hz cubic spline interpolation. Also, the detrending method, which 3 of 10. 146989886, 2025, 5. Downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for rules of use, OA articles are governed by the applicable Creative Commons license. Removes very low frequency trend components, is applied for every RR interval data to eliminate the non-stationarity problem. In our sample, none of the participants had a beat correction rate higher than 5%, M equals 0.19, SD equals 0.44, range 0% to 3.38%, indicating the high quality of our data. Following automatic correction, we visually inspected the ECG data and manually edited the noise segments within it, M equals 3.75s. As a result, the ECG data from 13 participants included data loss exceeding 5s due to movement-induced noise, and we excluded 2 participants whose R peaks were not properly identified due to numerous motion artifacts. Of note, removing participants whose beat correction rate exceeded 1%, N equals 5, did not significantly alter the pattern of the results. See table. Based on previous studies, we calculated the following variables using Cubios with default settings as indices for cardiac parasympathetic control in the time domain, Lee et al., Malik et al., Pereira et al. Square root of the mean squared differences between successive RR intervals, RMSSD, and PNN50 divided by the total number of RR intervals, PNN50. In addition, the absolute power of the high-frequency band, HF, 0.15 to 0.4 Hz, was calculated as it reflects cardiac parasympathetic control in the frequency domain, Lee et al., Watford et al., applying FFT-based Welch's periodogram. In brief, higher values of these variables indicate greater psychophysiological adaptability. Log transformation was conducted with HF to adjust for its non-normality, Kuo et al. We note that concerns about the interpretation of the low-frequency band, LF, and LF/HF ratio have been raised, Billman, and thus these measures were not included in the present analysis. 2.5 Data Analysis. We used SPSS 22.0 to conduct correlation and hierarchical regression analyses to test our hypotheses. Confidence intervals, 95%. Of regression coefficients were acquired by conducting 5,000 bootstrap resampling. In addition, based on previous research suggesting their influence on HRV, Quigley et al., Voss et al., age, gender, and respiration rate were entered into the models as covariates in step 1 of the hierarchical regression analysis. In step 2, grit was added to the model to test the degree to which grit contributed to the prediction of HRV. In step 3, self-control and conscientiousness were included in the Table 1 descriptive statistics and correlations for variables. Model to examine the unique contributions of grit in predicting HRV, above and beyond the effects of these related yet distinct psychological constructs. 3 results. 3.1 Descriptive statistics and correlation analysis. Descriptive statistics and correlation results are presented in table. As expected, there were significant positive correlations among HRV responses, i.e., RMSSD, PNN50, and HF, and among personal characteristics, i.e., grit, self-control, and conscientiousness. Self-control showed significant positive correlations with RMSSD, PNN50, and HF, 0.145 less than or equal to Rs less than or equal to 0.161, while conscientiousness showed a marginally significant correlation with HF, R equals 0.135, P equals 0.052, and significant positive correlations with RMSSD, R equals 0.159, P equals 0.022, and PNN50, R equals 0.166, P equals 0.017. Grit showed significant positive correlations with HRV measures, 0.215 less than or equal to Rs less than or equal to 0.236. 3.2 Regression analysis. To test the extent to which individual differences in grit predict HRV at rest, we conducted 3-step hierarchical regression analyses. In the first step, we included demographic information, i.e., age and gender, and respiration rate as a predictor for HRV responses. The results showed that while neither age nor gender predicted any HRV responses, table, respiration rate significantly predicted HF, B equals 5.707, SE equals 1.348, P 0.001. In the second step, we added grit as a predictor. Similar to the first step, age and gender did not predict HRV responses, while respiration rate predicted HF alone, B equals 5.855, SE equals 1.320, P 0.001. Additionally, grit significantly predicted RMSSD, B equals 6.769, SE equals 1.822, P 0.001, PNN50, B equals 5.693, SE equals 1.561, P equals 0.001, and HF, B equals 0.452, SE equals 0.135, P equals 0.001. Finally, to examine how grit uniquely predicts HRV responses compared to other relevant traits, we added self-control and conscientiousness in the third step. Grit still significantly predicted the HRV responses even when including the control variables. Specifically, only grit significantly predicted RMSSD, B equals 7.001, SE equals 3.062, P equals 0.021, whereas covariates such as age, gender, respiration rate, self-control, and conscientiousness did not. Similarly, variable M SD 1, 2, 3, 4, 5, 1 RMSSD, 2 PNN50, 3 HF, 4 grit, .SELFCONTROL, 6 conscientiousness, 29.531, 11.274, 5.627, 3.140, 3.192, 3.318, 14.761, 12.886, 1.03. 146989886, 2025, 5. Downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for rules of use. OA articles are governed by the applicable Creative Commons license. Grid was the sole variable that predicted PNN50, B equals 5.741, SE equals 2.740, P equals 0.037. Also, GRIT, B equals 0.514, SE equals 0.205, P equals 0.012, and respiration rate, B equals 5.949, SE equals 1.361, P 0.001, predicted HF overall. Individuals with higher levels of GRIT tended to exhibit greater HRV, i.e., RMSSD, PNN50, and HF, which is representative of adaptive physiological response. Table. Compensation type, whether extra credits or monetary, did not moderate the effects of GRIT on any type of HRV responses. PS 0.05. As a robustness check, we replicated the analyses by randomly splitting the data in half. The direction and effect sizes remained largely consistent. See tables S2 and. We further conducted facet-level analyses to explore whether the same patterns were found in the two subcomponents of GRIT, i.e., PE and CI, when predicting HRV responses. Results are presented in tables S4 and. Consistent with the results from the main analysis, most of the covariates, including age, gender, self-control, and conscientiousness, did not predict any of the HRV metrics, except 146989886, 2025, 5. Downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for rules of use. OA articles are governed by the applicable Creative Commons license. GRIT was the sole variable that predicted PNN50, B equals 5.741, SE equals 2.740, P equals 0.037. Also, GRIT, B equals 0.514, SE equals 0.205, P equals 0.012, and respiration rate, B equals 5.949, SE equals 1.361, P 0.001, predicted HF overall. Individuals with higher levels of GRIT tended to exhibit greater HRV, i.e., RMSSD, PNN50, and HF, which is representative of adaptive physiological response. Table. Compensation type, whether extra credits or monetary, did not moderate the effects of GRIT on any type of HRV responses. PS 0.05. As a robustness check, we replicated the analyses by randomly splitting the data in half. The direction and effect sizes remained largely consistent. See tables S2 and. We further conducted facet-level analyses to explore whether the same patterns were found in the two subcomponents of GRIT, i.e., PE and CI, when predicting HRV responses. Results are presented in tables S4 and. Consistent with the results from the main analysis, most of the covariates, including age, gender, self-control, and conscientiousness, did not predict any of the HRV metrics, except the effect of respiration rate on HF. When PE was included in the model along with age, gender, and respiration rate, PE significantly predicted RMSSD, B equals 5.122, SE equals 1.519, P equals 0.001, and PNN50, B equals 4.367. SE equals 1.332, P equals 0.001. Also, P, B equals 0.375, SE equals 0.103, P 0.001, and respiration rate, B equals 6.125, SE equals 1.464, P 0.001, significantly predicted HF. In the final model, which included self-control and conscientiousness, PE significantly predicted RMSSD, B equals 4.552, SE equals 1.963, P equals 0.021, and PNN 50, B equals 3.742, SE equals 1.723, P equals 0.031. Additionally, both P, B equals 0.376, SE equals 0.133, P equals 0.005, and respiration rate, B equals 6.056, SE equals 1.494, P 0.001, significantly predicted HF. A similar pattern emerged for the CI component of GRIT, after accounting for age, gender, and respiration rate. CI significantly predicted RMSSD, B equals 3.668, SE equals 1.542, P equals 0.018, and PNN 50, B equals 3.026, SE equals 1.352, P equals 0.026. Also, CI, B equals 0.212, SE equals 0.105, P equals 0.046, and respiration rate, B equals 5.609, SE equals 1.493, P 0.001, significantly predicted HF. However, these relationships became non-significant, PS 0.10, in the final model that controls for self-control and conscientiousness. For discussion. Here, we investigated the association between GRIT and resting state HRV, a well-recognized psychophysiological marker of well-being, Kemp et al. Our results demonstrated that GRIT was positively associated with all three resting state HRV indices including RMSSD, PNN 50, and HF. These findings extend previous work that examined the relationship between GRIT and stress-induced HRV, Sylvia et al. Considering that higher HRV has been linked with reduced threat perception and less prioritization of negative information, Matro et al. That might lead to decreased stress levels, Thayer et al. Gritty individuals who appraise situations more positively and view setbacks as opportunities to learn may tend to achieve more adaptive health outcomes. Total GRIT and its subcomponents showed similar patterns in predicting resting state HRV measures in positive directions. However, the effects were relatively weaker for the CI component. 1469896, 2025, 5, downloaded from https://onlinelibrary.wiley.com/doi/101111/sci-p.70064, Wiley Online Library on 15/05/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions, on Wiley Online Library for rules of use. OA articles are governed by the applicable Creative Commons license. An RMSSD can differ based on race, Reed et al. Wang et al. Therefore, the relationships between GRIT and resting state HRV may vary across cultural contexts. However, a recent meta-analytic study has shown that the beneficial effects of GRIT on health outcomes are invariant across cultures. See HOETAL 2022 for a review. This might be because GRIT can satisfy basic human needs, which are important in human well-being across cultures. Chen et al. Deci and Ryan. Specifically, gritty individuals, who tend to follow self-selected long-term goals regardless of socio-cultural values, might fulfill their autonomy needs, which, in turn, can boost their well-being. Supporting this notion, empirical studies have found that GRIT is positively related to autonomy needs satisfaction across cultures. Jin and Kim, Marcelo Torres et al. Thus, we believe a similar pattern might emerge in the context of psychophysiological adjustment across different cultures. Nevertheless, future studies should consider expanding the sample to include populations with more diverse demographics, racial, and cultural backgrounds. Third, it is possible that participants' physical activity levels may have influenced the HRV results. Previous research has established that physical activity and fitness are significant factors affecting HRV, Carter et al., Rennie et al., Rossi and Thayer, Sloan et al. For instance, individuals who frequently engage in fitness activities, i.e., high fitness group, tend to exhibit higher vagally mediated HRV compared to those who do not exercise regularly, i.e., low fitness group, Rossi and Thayer. Thus, one might argue that the observed relationship between GRIT and HRV is due to a spurious effect of exercise. However, for this explanation to hold, a strong relationship between GRIT and exercise would be necessary. Prior research suggests that the correlation between GRIT and physical activity is weak, if present at all, Rs equals 0.15 to 0.18, Reed et al. Reed, making this alternative explanation unlikely. Regardless, we encourage future research to replicate our findings while controlling for individual physical fitness. This study finds that resting state HRV is associated with GRIT over and above other psychological factors, i.e., self-control and conscientiousness. Identifying physiological markers of GRIT holds significant theoretical and practical implications. Theoretically, it provides an objective validation of GRIT, deepening our understanding of how this trait influences not only achievement but also psychophysiological well-being. Practically, it provides a fundamental basis for intervention. Since GRIT is a malleable trait influenced by other psychological and contextual factors, Allen et al., Cross, Duckworth et al., Park et al., developing interventions to enhance GRIT may help people improve stress management, build resilience, and contribute to better overall health outcomes. Author contributions: Jae-Hoon Yoo, Conceptualization, Data Curation,